Hi everyone, this is going to be a video on Kangaroo, and as I said in class, this is a kind of optional tangent in that these kind of nodes and components aren't essentials, and so that you can do everything in Grasshopper the way creating points and creating curves and using data trees would be. But if looking at tensile surfaces and those kind of forms, these are a really nice set of tools to do that. So Kangaroo generally works with meshes. So first thing we're going to do is make a surface and convert it to a mesh. And the first example we're going to do is like pitching a tent. So we kind of start with the flat tent. We choose the anchor points of where the tent is going to be anchored around the edges, and then inflate up the middle. So to do that, I'm going to draw a curve from the Rhino menu, and I'm just going to make some random shape. My gumball's. Let's just smoothen this out. Okay, that's fine. Okay, so I'm going to link the curve into Grasshopper by curve and right-click set one curve. And this is already selected, so I don't need to reselect it. And then I'm going to internalize it so that it saves it into Grasshopper and I can delete it here. Now we have that curve there. So if I do surface like this, that curve would become a surface. And if I do mesh, either the curve like that or the surface, it wouldn't really make a difference, would become a mesh. And if you see the kind of what we'd call the mesh topology, where the points and the edges are in this mesh, there's a number of different ways to control a mesh so that I can have more control on how this is divided. One of them is mesh surface, which is more used for what might be called an untrimmed surface. So if I do a square, it basically will make an untrimmed surface, where the way Rhino works, that if I do a more kind of curved shape, it's making this larger surface and then trimming it back to that curved shape. So this component of mesh surface is on the untrimmed version, which gives us this larger boundary than we want. In that sense, it's not very useful for this kind of curve to use this component. So I'm going to disable that and turn it off. Next choice is mesh brep. And this means that if it's a poly surface, I could mesh that with mesh brep. And if I turn off this mesh so I can see, this gives me a very, well, the default gives me these sort of very long triangles, but a very low number of triangles. And I can control the details here with settings. So I would need mesh settings for that. And just in case you get to it, that the quad remesh settings and the mesh settings are a different set of settings. And here I can control the minimum and maximum of the number of triangles that I'd want to get. So I can see there instantly how that's controlling the mesh. It's sort of giving me perfect squares in the middle and then triangles around the edge by controlling the minimum number allowed. I don't really need a maximum. And you can go the minimum edge length, the maximum edge length, about angles. There's a lot of different ways to control that mesh with that setting. So that's mesh brep. Then we have the kind of quad remesh and tri remesh settings. And you can either put an existing mesh into this or just go direct from the surface. So if I was to put that in there, turn this off, that I can see this. And this is where you can kind of see the quads in the middle, and then they kind of become less square and more just these random shapes to adjust to this curve. The other thing that's very significant about quad remesh and tri remesh is that the data structure is completely dismantled. So if we broke up this mesh with explode mesh, this might be it's a plugin and I don't have it installed. Okay, I guess more on that later. But let's do face boundaries, I think. Yeah. Okay, face boundaries. So this is not going to give me the mesh faces, but it's going to give me all of these quadrilaterals as curves. And I can look at the list item. And if I just want like 10 curves, for this to select 10 curves all in the list, just select the first 10, I can just add all these plus, and then see, they're all over the place. They're not in an order, where if I write these and solve, oh, that's one mesh. Let's do face boundaries on that mesh. See there? They're all together, right? So this quad remesh sort of dismantles the data structure, so does tri remesh, and that's just important to kind of note. So if I do tri remesh, it's trying to achieve triangles that are sort of similar to each other, but it's not perfect. And you can set the length here. One thing that's very careful is if you have a mesh that's the size of, let's say CVAD, the floor plan is CVAD, and then you tell it to divide with a mesh triangle that's the size of a pin, it will try to do it and try to create, 30 million mesh faces and crash your computer. So it's a good idea before you ever change the settings in the length of the tri remesh, just to measure. So in Rhino, I'm just doing distance to see roughly that's 52. So I'd start with, let's say 50, and then I can reduce it from there. So this is kind of controlling the density. As I bring that down, it's getting really dense, and as I bring it up, so this is the target length, this length from here to here on the mesh. Okay, so let's use the quad remesh to go forward with Kangaroo. But Kangaroo, I'm going to need some sort of mesh. For Kangaroo and this example, I'm not so much interested in the data structure, but I just mentioned that because meshes get used a lot, and maybe that data structure might be important for something else. So Kangaroo is pre-installed as a plugin. It used to be a separate plugin, but for the last versions of Rhino, it has just come pre-installed, but it still sort of has its own menu. These are all kind of tools around sort of physics and form, mesh relaxation. So goals are can be like forces. And the main principle of Kangaroo is you need one of these solvers. Let's just do the Banksy solver. And I can see just on setting this up first, that has a reset and an on. So I do a Boolean toggle. And that is just whether this component is on or off, whether it's running, because it's a heavy component and sometimes you might want to actually just totally turn it off. And a button for reset. Sometimes when we change a mesh, it won't fully reset. So we need to actually hit the button and that will reset it. It's currently off with false. So I'm going to do, you could put all the goals in one by one, holding shift into the goal objects, or use a merge, which would probably be more common. So the general format for almost all of these scripts is I'm going to start with a mesh. I'm then going to create a number of goals for the mesh. And then I'm going to solve. And this is, just most Kangaroo scripts are in this sort of format. So the first thing I always want to do is use what's called show command. And if I do Control-Alt, I can see that's in main, just under the Banksy solver. It's there as show. And what that means is the first thing I want it to pass through is the mesh itself. And that's means when I go looking for what's coming out here, I can see that the mesh will come out. And that means I can just flatten the list item, get the first item. And now as long as this show is the first item, then the first output will be the mesh itself, because that's really what I'm most likely looking for. So the next thing I'm going to do is I'm going to put a load on it. And if this load was downward, that would be gravity. If it's upward, so 0, 0, 1, where the z-axis is 1, so this is an upward load. So if I think about this as a tent that's flat on the ground currently, then I'm going to use a positive force. I inflate the tent or push the tent upward, and then I need a weight. And the weights here are not physics-based. They are not in units of anything. They are just, if I have the total weight of the structure is really, really heavy, but then I have the up force as really, really strong, well then if one is bigger than the other, it will sort of inflate too much. And if one is less than the other, it will start collapsing. But they're not actually in sort of kilograms or newtons or any sort of units. They're just relative to each other. And in a more mathematical physics engineer software, these things would be the same sort of logic, but they would be real world units. So that's my load. And the next thing I want to do is I want to say that each of these edges, whatever they are, they have the ability to stretch or to change from what they currently are. So that would be edge lengths. And I need to look at the inputs. It needs a mesh as its initial thing. So back to this mesh. And what is the length factor? That is how much the edges are going to be able to change. And let me turn this on now and turn everything else off. There's already an issue with it, but I'm deliberately turning it on with the problem so that you can see what happens. So see here, I've got the mesh coming through. I've got all the lines. Just in case the data structure happens, I'm going to flatten this list, and then I'm going to list item, because I only want the first item. I don't want all the kind of edges separately. And there we go. So this is our mesh. So what happens when I turn this on, I can see it spreads out. It would have gone upward ways. Okay. There's something wrong. Let's see how this changes it. We're just looking in case something changed. Okay, I'll figure out the rest in a minute. But anyway, the next thing to do would be to put the anchor points in. And if I take the original mesh, so I'm going to turn this off for a second. So on the original mesh, I have some different ways of getting inside of that mesh to the sub-objects. One of them is deconstruct mesh. Actually, I know what I did wrong. That there is point, and that should be the points on the mesh, not the mesh. So deconstruct mesh gives us access to the points. So now just with that, and that's all points on the mesh, I redo this, and let's see what that looks like. Yeah, there we go. That's what should have happened. So it has no anchor points, and it just quickly goes up. If we wanted to slow it down, we can put a slider into dampening and turn it down a little bit. And there we go. That's what's happening to our mesh. It's basically not anchored to the ground. So it's just going up and floating. So let's turn this off for now. So this is how I get all vertices with this V component. I also get all the normals, which are the vectors pushing away from the initial geometry. The colors of the mesh, which there is no colors on this mesh, but meshes can hold a color, and the mesh faces. And you see the way, if you see that list there, they are the indices or indexes of the initial list. So if we have this list of points, like this, and each one of those points has a number in this ordered list, well then this is saying the first face is from point 0 to point 4, or to the 4th item in that list, to the 5th item, to the 6th item. And that's a face with 4 vertices as a thing. And then the second one is 0, 6, 7, 8, 0, 8, 9, 4, and so on. So that's how faces are listed there. And another thing that I could extract from my mesh is the mesh edges. So I'm only really interested most of the time in E1 and E2, and that is naked edges, which are edges on the edge of the mesh, like the border, and clothed edges, which are ones that are not on the border, and it just separating one from the other. And there's a nice component that's called naked vertices. And this gives us not the edges that are naked, but the points that are naked. So, and I can see this point here for naked points, right? So there we go, points on the edge, clothed points, the ones in the middle. And if I look here, this is again the indices, the number of where these points appear on the list of total points that are coming into it. So they wouldn't be, if you did list item, see here, if we did list item, so from total vertices, which ones are naked, select those numbers, then we get the same thing, right? So, okay. So I want the naked points around the edge, to be my anchor points, kind of like, think of it as a tent. They are the, what I'm sort of putting the forks in the ground and tying that tent down. And then the strength, these are relative to the numbers 2 and 4 and the numbers above. I'm just going to put 10,000 or 100,000. That basically means when I put something in the ground, it is tied to the ground that it will never float away because the strength is just big. So just any random number. You could play around with a slider and see how big of a number you need. The answer is probably like 10 or 11 or 12, like something small, but you know, default is just put a big number so that you never let it float away. So let's turn off all stuff here, Control Q. And now let's turn this on here, and I can start to see some inflation happening. So I've basically taken that mesh. It has the same topology. It has the same number of points, the same number of edges, but it's let them go up. And as I change that topology, like changing the net, let's say I went to the tri-remesh or quad-remesh, or change that initial mesh, that is the kind of net material of how this thing can stretch, right? So what I can change here, I can change the load, which is vertical, and bring that down. I could change how sort of stretchy each of the edges are. And in this way, now I've sort of created this sort of inflated geometry. If I was to, let's say, try remesh, okay, and we said that this was sort of around 50 as its default value, so there's the length. I'm going to use Control-Alt to just grab that and put that to there. So now I would need to do the reset button because I totally changed the settings. And I can see how that inflates differently, see? And now I have triangles. And as I change the number of triangles, that's going, let's go super big triangles first. I can see how this form might be different. So there's the inflation of it. You see it's running now. It's sort of figuring out until it stops and then it says converged. And if I turn this down, this is going to be way slower because it has way more geometry in it. There, it's figuring out the forces of what's happening. That's also super slow because I have the adapting on. Otherwise, it would go up pretty fast. Okay. So as we continue on, let's make this smaller just so that we can make changes and we're not going to get any slow results. Okay. And we can turn this a bit so that it calculates faster. There we go, like that. And okay, so similar to what we did in some of the previous examples, I want to do a dispatch pattern and do two series components where I'm going to use these to create zeros and ones. So I want the set number, the step increase to 0 and do 2 of them. But on the second one, change the start position to 1. Sometimes this doesn't change if you don't hit commit changes. Okay, and for the count, I'm going to use a 1 to 20 slider. Okay, and you've seen this from before, but if I merge these and just look at what I've created, so let's merge this and this, and delete this, I don't need it. So if this is 1, I get 1 0 and 1 1, 2 zeros and 2 1s, 3 zeros and 3 1s, went down and so on. So if I use this as a dispatch pattern for the naked points, let's just have a look at what we've done with point here. So that means select 3 points, then don't select the next 3, and so on. And that can be controlled with this. See? And when it gets around the edge, when it gets to the sort of start and end and comes around, it might have this weird pattern here. But let me just increase this, or rather decrease this. So possibly based on the way I drew my curve, my ordered list is not perfectly ordered. What I might do is I might go back to using this mesh. Let's see if that does it better. Yeah, so now this is more ordered around the edge. It's 3, then not 3, then 3, then not 3, 3, then not 3. Let's use that for now. Okay. So basically I want to use one of these points as my anchor points. So instead of using all the points around the edge as anchor points, I'm just going to use some points, then not some points, then not some points. Go full speed and okay. So this is the 11 points that are anchored. 12 points that are anchored, then not 12 points anchored, then 12, and so on. And maybe I want to increase this a little bit more. Okay. And that way I can create this sort of arches around the edge. And then I'm going to load the example I already created with some more kind of complicated examples. You can find this file in the Canvas set of files. I added a date. But I want you to get used to reading files as much as writing files. So just kind of seeing what's happening here. And this is currently on false, so I can turn this on true. This is very similar to what I just created. Only difference is I also added, we'll just do a zoom on the last output. I also added to randomly select points. So from here, from total points of the mesh, to get the list length of the mesh. So how many points are there? There are 2,933 points. Then multiply a number by between 0 and 1, which will get a percentage of those points. So in this case, it's 232 points. So get 232 random numbers and select integers so that they're round numbers and not decimal point numbers. But select 292 points and also make them into anchor points, but not with a weight of 10,000, but with some lower weight. And that's selecting all these points in the middle and basically dropping them down as well. But other than that, it's quite similar. And then you can download this file and see if this goes up to 17. Now they're fully anchored. But if I make it slightly less, they might not be full anchor points, but they still have a lot of weight to them. So that's what happens if they're not on at all. But they might control them from going too high. And then at the end, I also did this Catmull Clark, where Ed Catmull is the founder of Pixar and did his PhD on subdivision surfaces. And this is just to take this mesh, which is a lot lighter. See there? That's what's actually coming out of Kangaroo. And then this subdivides each mesh cell into, so it does 2 subdivisions. See there, the level. Divides it into 4, then divides each one of those into 4, so it divides into 16, and then smoothens everything. So you can see there's sort of 16 cells inside that square. And if I turn that up to 3, that would divide each cell into 4 again, so it would get up to be a lot smoother and a lot more geometry. And then that's the same. In this example, which go through and just start at the beginning and turn one thing on at a time, I started with a chair. Do a zoom on the chair. And I just drew this, using boxes and did a solid Boolean to make it into one shape and then in one BREP. And then I internalized the BREP. So convert that to a mesh using mesh BREP and then quadri mesh with 1,000 mesh faces. So you can see this gets a nice kind of to the edges mesh version of the chair. Deconstruct mesh to get the vertices, and in this case I'm using the normals. And the difference in this case is rather than say the load is in the direction just vertical or like upward or downward, i.e. gravity or sort of inflation, upward like a tent, the force is along the normal, right? So I can use this display vectors to see a vector display the other way around, right? So on each of the vertices, display the normal, right? I can see in this case, the normals are all pushing away from the initial B rep, right? And on most surfaces, you get, like, even if you have a very curved surface, looking at the vectors gives this really nice sort of set of arrows that are perfectly tangential to the surface at every point. So this is trying to push outward where all those arrows are as our anchor points. Other than that, edge lengths, and then also the smooth. So let's turn off smooth first. Or actually, I think I can just turn this to 0 and see what this looks like without smooth. I need to turn the preview at the end off. Okay. So this is without smooth. I can see different things that are happening when I move around. My anchors is not having a ton of control unless it's 0. Okay, that's acting to inflate it. That's the pushing out on the normals. And then if I turn smooth on, it's just going to smooth the end result. So we go back to where I was there. Yeah. And you can kind of play around with what you want to inflate and what you want to sort of act as an anchor, and sort of play around with interesting inflation techniques that can be kind of fun. And the rest of that is the same. And turn that off. And I, just to save computational power, turn these to false. So they're not actually doing anything. And then in this last example, this is more complicated for sure. And in this case, I've drawn mesh faces and created kind of floor surfaces with gaps in the mesh, and then another floor, and then I created these kind of walled chambers that sort of are completely vertically open, and all of these squares are perfectly lined up to each other, so that when I create a mesh, it's just one continuous thing like this. Refine is, if you see that, let's say in this panel here, I have 4 squares. If I compare refine, I basically a form of subdivision, so I've made it into 16. If I increase that, I'll just increase the amount of squares that I have. And then again, I'm using naked vertices to get the naked enclosed points. I'm using show to get the mesh. Using edge lengths, I'm using smooth. But I have, some other components here, Raj and sphere collide. They're different, but you can play around with how they would affect or different things to do. Same, merge, flatten, goal objects, and going that way. Here I've added a data dam, and that's where you just go data dam. And that's when you have a very heavy file and you have something that takes, like, let's say a minute or 10 minutes to calculate on this side, and you don't want any sliders that are on the left side to change what's on the right side, because it would slow it down. So you make this data dam, and those sliders will only change the script up until the data dam, and then you'll have to press play when you change something. So if I do true here and I generate my mesh, I can see this is the mesh is generated, and I've deliberately dampened it so it's going kind of slow. And when I want to take it at a fixed position, I can say play here. And now that position, even though this is still running, it's still changing on the left side. But what's on the right side now is at the point that I press play. So what I've done here is use some plugins to thicken the mesh. It's given it a sort of thickness. So it has like a top, a bottom, and a side. And then I've also smoothened that so you can kind of see what that looks like. And there's a lot that could be played around with here so that this was parametric, and we could choose just from a list of numbers where we want these walls to be and where we want verticals to be and where we want vertical holes to be, and make this into a mesh. You could do that as a bookshelf. Just flip the axes to be more vertical, but that's sort of an interesting way to smoothen out a mesh with this script. Okay, so that's what that looks like. Okay. The other thing that I mentioned in class at the beginning was the installing of plugins. And if you load this file in particular, you will have probably already been prompted to, do you want to install the plugins? You can just go yes that way. Another way to do it is to do, package manager. And you would search a plugin such as MetaHopper. And it has this check mark here, which means it's already installed, but you can choose the version. Most of the time you get the latest version. Sometimes the latest version might be incompatible with other plugins you have, and you have to get an older version. So you can choose that there. And for another way to install plugins, I made a different video on plugins to manually download files, unlock them, and put them in the right place, where you go File, Special Folders, Components. And you would drop them in here. So I don't have that many plugins in my Citrix Rhino, but that's all there. All right, see you next week. If you want to explore Kangaroo further, as I said, it's not part of the fundamentals of Rhino and Grasshopper. It's more this tangent towards this inflating forms with meshes. But if you have any questions, always just ask. All right, see you next week.